to module 14.7. In this lecture video, I'm going to show you how to dealing with distance, rate, and time problem using our rational equations. So even though we already done distance, rate, and time problem in other modules, these four example I have, some of them is worded slightly different than other one we done, so that actually creates a different set of equations here. Okay, so some of the technique we used before can still be used. All right, so let's check out these problems. Luis can drive 3 times as fast as Carlos can ride his bicycle. All right, so when I see the word 3 times as fast, I gotta translate. All right, I'm translating, so I'm comparing between Luis and Carlos. All right, since Carlos lives at the end, Carlos is gonna be X. Luis is gonna be 3 times as fast, so that will be 3x. So what I just translated are the rates. All right, or their speed. Be very careful. This kind of strange. Luis' speed. Luis is going faster than Carlos. If it takes Carlos 2 hours longer than Luis to travel 15 miles, how fast can Carlos ride his bike? All right. So here we go. What does it mean? It takes Carlos 2 hours longer than Luis. So it seems like we need to translate for the time as well. Okay, it seems like we need to translate for the time as well, but we do, but we're gonna do it slightly different. Okay, we're gonna do it slightly different. Normally, the problem that we done before, we translate for the rate and the time, but these problem here, okay, we're gonna look at it from a different perspective. It takes Carlos 2 hours longer than Luis to travel 15 miles. So what that means is both of them is traveling 15 miles. It's gonna take Carlos 2 more hours. Why it takes Carlos 2 more hours? Because Carlos is going at a slower speed. Okay, think about this. Luis is driving, Carlos is riding his bike. So Luis is gonna get there first. Okay, so the time that Luis spent is going to be less compared to Carlos. So if it takes Carlos 2 hours longer than Luis, okay, so this phrase right here is what we needed to write out the equation. Who takes more time? Who takes more time to go that same 15 miles? Who takes more time? Carlos. Carlos' time is greater than Luis' time because Luis is going faster, but so the time is less. All right. So Carlos takes 2 hours longer than Luis. So since Carlos' time is already greater, okay, so to have them equal, to make their time equal, either Carlos will need to subtract 2 hours to equal to Luis' lesser time, or Luis can add 2 hours to equal out to Carlos' time, okay? Or we can say, well, if it takes Carlos 2 hours longer than Luis, that means the difference between their time got to be 2 hours. Think about that. It takes Carlos 2 more hours, right? Carlos takes 2 additional hours, so that means the difference between their time got to equal to 2 hours. So that's the concept we're going to use to write out the equation. The time it takes Carlos minus the time it takes Luis. Okay? the difference between their time is actually 2 hours. So we used to use the equation distance equal to rate times time. All right, but the same equation here, if I solve for the time is always distance divided by rate. If I divide both sides by r, then my time is always distance over rate. So these distance, rate, and time problem, we're using time to write out our equation. All right, so for the time of Carlos, distance over rate. Okay, Carlos, sorry, I just wrote Luis. Carlos is 15 over x minus, remember now, Carlos takes more time, so Carlos' time is greater. You got to use greater, subtract less to equal to positive 2. Minus 15 over 3x together equal to 2 hours. Okay. All right, now let's solve for x. My LCD between these two denominators got to be 3x. So I'm going to multiply every term by 3x. Even the 2 got to times by 3x. So top x, bottom x cancels out. That's 45 minus top 3x, bottom 3x cancels out, minus 15 equal to 6x. So 45 minus 15 is 30 equal to 6x. Divide both sides by 6, my answer, x equal to 5. So how fast can Carlo ride his bicycle? So remember now, when we first translated x and 3x, they were representing rates. So how fast can Carlo travel? 5 miles per hour. Okay, 5 miles per hour. Luis is driving at 15 miles per hour. Okay, so as you can see, using rational equations for distance, rate, and time problem, we're basically using the time, the concept of time, to write out our equation. Okay, let's check out another one. So we done something similar to this. Plane A and B. Plane B is flying 95 miles per hour faster than plane A. Find the time it takes for plane B traveling 1785 miles if it takes plane A the same amount of time to travel 1500 miles. Okay, so why the plane B go more miles than plane A? Well, because plane B is going faster. Going faster means it cover more distance. But since the problem says, okay, find the time it takes for the plane B to travel that many miles, if it takes the same amount of time for plane A to travel 1500. So that means the time for plane A is going to equal to the time for the plane B. So we're going to set the time equal to each other. So here I got plane A and B. So my first phrase or my first sentence, plane B is faster than A. So A is listed at the end, so A will be X. So plane B is going to be 95 plus X. Faster than means we're translating for the speed rate. All right. So the distance for A is going to be 1500 miles. Distance for B is 1785. All right. Find the time it takes for them. So this problem is finding the time. All right. For each one to travel those distance in the same amount of time. So let's take a look. The time it takes for the plane A to travel 1500 miles is distance over rate x, set it equal to the time it takes for the plane B to go 1785, distance over rate. All right, that's how we set up using the concept of time. Now, I do see two fractions equal to each other, so I'm going to use cross product to help me solve for this, okay? 1785 times x, 1785x, set it equal to, as you seen before, when I write 1500 times 95 plus x in the parenthesis. Eventually, the 1500 will times the 95 and the x. So we can go ahead and do that. So they save us one extra step. 1500 times 95. So 1425 00 plus 1500x. All right, let's move the 1500x to the other side, become minus. So that's 1785 minus 1500. So that gives me 285x. So that equal to 142500. Divide both sides by 285. 14. All right, 500. Hang on a second now. Hang on a second. 500. What does 500 mean? The 500 represent x, which represent the speed for plane A. So the plane B is 95 plus 500, which is 595. But this question is asking finding the time it takes. All right, since we already said the time equal to each other, all I got to do is find the time of one, which is going to equal to the time of the other one. So the time of the first plane, 1500 is the distance, right? Time equal to distance over rate. The distance for the first plane is 1500 divided by the speed, which we just found is 500. So the answer is 3 hours. So it got to be the same thing for the other one. Check it out. 1785 divided by the speed, 595. It got to be equal to the same thing, 3 hours. So you will take both of them 3 hours to travel their respective distance. Alrighty. This is a very similar to going somewhere and coming back. Justin recently drove to visit his parents who live 864 miles away. On his way there, so we go in there, his average speed was 21 miles per hour faster than his speed on the way home. There and coming home. All right, so let's go in the parents' house and coming home. Faster than, so I gotta translate their speed again. On the way there, speed is 21 miles faster than on the way home. So home, on the way home, got to be x. On the way there is 21 faster than means plus x. So I just translate for their speed. If Justin spent a total of 24 hours driving, whoa, hold on a minute now. What does that mean? Find the two rates. Now, distance there and distance back got to be exactly the same, 864. But how can I use this idea of total 24-hour driving? Okay, if Justin spent total 24-hour driving, that means the time it takes for them to get there plus the time it takes him to come home together got to equal to 24 hours. He is actually literally driving for 24 hours total. Of course, he'll probably take a break, but the total time it traveled was 24 hours. So we know the distance got to be the same there and coming home. So the time to get there, distance over rate plus the time coming home, distance over rate together equal to 24. So here I got two different denominators, so my LCD got to be x times 21 plus x. All right, so let's multiply every term by the LCD. So the first denominator is missing compared to LCD is missing the X. So, because the 21 plus X will cancel out. So that will be 864 times X plus, all right, LCD times the second term, the X will cancel out. So the second denominator is missing the 21 plus X. So we take that times my numerator, 864, equals, all right, my third denominator don't have neither X or 21 plus X, so nothing will cancel. We'll take that times the numerator 24. X times 21 plus X. So now we see this as 24X times 21 plus X. So here when we do a distribution, we use 24X and distribute. This is using 864 to do a distribution. All right, so let's check it out. Plus, all right, X64 times 21. Let's see what that is. $18144 plus 864x, set it equal to 24x times 21. 24 times 21. 504 plus 24x times positive x is 24x squared. Uh-oh, this is big. I'm actually gonna end up solving a quadratic equation with bukus of big numbers. All right, let's see. X64 plus X64 on the left side. X64 times 2 is 1728. 1728x positive 18144 equal to 24x squared. I'm gonna put this in front of the 504. X. All right, lovely. Alrighty, let's move the 1728 and the 18144 over. So 0 equal 24x squared, still the same. 1728x come over, become negative. That will be 504 minus 1728. 504 minus 1728. Give me negative 1224. 1224x. All right, positive 18144 come over, become negative 18144. All right, so these are humongous numbers. So let's see if we got some kind of common factor we can factor out. Wouldn't it be great? This 1224 can be divided by 24. I don't know. Let's try it. Please be even. Yes, negative 51. Thank God. All right, 18144 divided by 24. Please work. Please. Yes, 756. All right. So if I factor out 24, that gives me x squared minus 51x minus 756. All right. This is not as bad. So as you can see, if I only have two terms right now, so if I divide both terms by 24, that allows me to get rid of the 24 here. 0 divided by 24 is still 0. So I can practically ignore this 24 I factored out. So all I'm dealing with is going to be 0 equal to x squared minus 51x minus 756. So what I'm looking for here is a difference. What times what is 756 have a difference of 51. So let's take some thinking here. 756, okay? 700s. Think about this. Something times something go into 700s. You know 20 times 30 is already, okay, it's already in the 600. The product is about 600. So what I can do is using 20s over 30s, work my way up a little bit, okay, to see, how, to see what number I would need it to go into 756. So I'm going to use from the 30 perspective, okay, just to see. I don't know. I really have no idea what the answer is. I just know a little bit over 30, a little bit over 20, somehow you would get me close to 700 something. So 30, I know 30 is not going to go to 756. 31, 756 divided by 31. I'm going to look at the difference. The difference, so this is actually 31 and 24. The difference is actually not that big. So I got to think about their difference to being 51 at the same time. Okay, so this is tricky. All right, let's try again. 32. 2 times 3 ends with a 6, so I can try with 32. Second entry, 32. All right, so I'm pulling away now because this is 23 something. So 32 minus 23, my difference is getting larger now. 756. Let's see, maybe I need to go smaller. Maybe I need to go under 20. Maybe, I don't know. Let's try 19. Because I want my difference is 51. It's pretty big. 756 divided by 19. Oh, you see that difference is 20. Okay, so that's good. 18. 756 divided by 18. 42. 42 and 18. 42 and 18. Still not big enough difference. So let's go even smaller. 17. 756 divided by 17. I'm not just picking any number. I'm actually knowing 7 times 8 end with a 6. So I'm only using the backside number. What times what ends with a 6. That's 44. 16. 756 divided by 16. That's 47. So let's go smaller. 5. Nope. 14. 756 divided by 14. 4 times 4 ends with a 6. Worth a try. So now I see a 54. 54 minus 14. The difference is 40. So I'm getting closer. I'm getting closer. Okay. This is pretty extreme differences. Even though 20 times 30 is close to 600, but I do need that difference of 51. So I do need these two numbers to be a little bit, apart. So the next one I'm going to try is 13 because 3 times 2 ends with a 6. Nope. All right, 12. 63. So 63 minus 12. 63 minus 12. Bam, 51. All right, so that will be 12 and 63. All right, need to be negative 51 in the middle, so that's negative 63 and positive 12. All right, set each factor equal to 0. I know my x equal to negative 12, the other x equal to 63. All right, so my x representing speed, which cannot be negative, so I cannot use negative 12 for answer. All right, find the two rates. X is 63. So the other one is 21 plus 63, which is 84. So that's a speed on the way there and on the way home. All right. Whew. Big numbers, big numbers. Got to think about it and work at them. So maybe I should not have mentioned 20 times 30 because the difference is only 10. I should have mentioned greater differences. Like 10 and maybe using 10 times 60, that will give you about 600, or 10 times 70, something like that, to have a greater difference. All right, this is very interesting. We don't paddle the boat question before, or the airplane question before. So this one says a boat can travel in the 52 mile in the still water if it travels 165 miles with the current in the same length of time. See right there, same length of time as it traveled 147 miles against the current. So against the current is slower speed, same amount of time, I cannot go quite 165 miles. All right, so here we got going with the current and going against the current. All right, I got distance, I got rate, and I got time. My distance with the current is 165, against it 147. All right, what is the speed of the current? So I'm going to say my x is speed of the river over the current. Remember, we mentioned the speed of the boat's got to be in the front, okay? Boat got to be in the front, just like the airplane going with the wind and against the wind. Got the speed of the plane or boat got to be in the front. The wind and the current got to be on the back. With the winds faster, we add. Against the wind is slower, so we subtract. So the time is going to be distance over rate. Since the problem says the same length of time, that means we're going to set the time equal to each other. So the time rolling with the current, okay, is going to equal the time traveling against the current. So that would be 165 over 52 plus x, set it equal to 147 over 52 minus x. So I'm going to do a little bit of cross product. All right, 165 times 52 and times negative x. 165 times 52, 8580, minus 165x, set equal to 147 times 52, 7644, plus 147x, right? 147 times pi to the x. This is a linear equation, so let's move the 165 over, and we can move the 7644 to the other side. All right, 147 plus 165. 147 plus 165. 312. X. All right, 8580 minus 7644 go the other side, become negative. Typing one too many subtraction sign here. Delete. 936. So that would be about 3 times. Divide both sides by 312. All right, x equal to 3. So that means the speed of the current, that's what the question is asking, is 3 miles per hour. That's all it is to it. So it turns out these application problems, in order to set up as a rational equation, we have to basically using the concept of time to help us set up these equations. Unlike previously in other modules where we used the distance formula, here we actually use the time formula. Okay, to write these equations out as a rational equation. So that will conclude this lecture video. Thank you for watching.